what is Rover, how do you program it, and what is the UART on there, and let's just talk about Rover. So I'm Adam Wilson. I'm the founder of Sphero. I'm also on a couple of social media platforms. If you want to find me, watch any of my other robot stuff, you can find me out there. And so I'm just going to go through our schedule. We're going to start with ways to program Rover. We're going to talk about the Rover tech specs. So what are all the sensors? How do they work? We're going to talk about the Rover SDK. So, how do you talk to Rover? What's the API? What's the UART? What does all that stand for? Then we'll quickly talk about Raspberry Pi, what that is, and why we're talking so much about it. And then also we're going to connect a Raspberry Pi up to a Rover through the UART and send a couple commands over our REST-based interface. So stay tuned. We're going to do all of that in about 15 to 20 minutes. So SpheroEDU and Rover. One thing that we got asked is, well, I'm not that into Linux, or I don't know it yet, and that's actually fine. The whole point of Rover was if you knew how to use Bolt, or if you've ever used our SpheroEDU app, then you are in the right demographic and you have all the right skills to kind of pick up a Rover and start learning this stuff. So if you got a Rover out of the box, you can use the SpheroEDU app. So you can just download that app on iOS, Android, Chromebooks, Mac. It's kind of universally available. And that app will allow you to program all of our robots, but also Rover. So if you grab that app and you have a Rover, you'll be able to go and grab the blocks. So it's a block-based programming along with JavaScript. So you'll be able to use these blocks and drag them over. So say you drag a block over that says, I want to go forward for 10 seconds and at half speed. It's kind of a long distance, but you drag that block over into this program, and then actually in the corner of that SpheroEDU program, if you click up there and then you go down to JavaScript, it will turn your block into the JavaScript command that it would actually be. And what's really cool about that is you're actually getting introduced into our SDK at that moment. That's how the robot kind of likes to see data. That's how it likes to interact with people, is the way that you see that. So meaning when you send it an LED command, like what color, you're going to send it RGB, so red, green, and blue, and a number out of 255. And you'll start kind of seeing that stuff in the JavaScript part of the SpheroEDU app. So within the SpheroEDU app, you'll also, like I said, there's blocks, and then you can switch to JavaScript. Once you learn how to use the JavaScript, you can start getting a lot more advanced and using our Rover kind of the way we intended. So let's talk about a couple of cool tech specs on there. What kind of stuff could you get within that SpheroEDU app? One thing is the programmable LEDs. So the front LEDs, the side LEDs, and the back, those are all RGB LEDs, again, red, green, blue determined LEDs. And so you can make like headlights or side lights or tail lights and kind of have the whole robot doing interesting stuff using the LEDs. It also has infrared sensors. So if you're familiar with our Bolt program or product, we put infrared on there so that we could actually communicate with other robots. Infrared is like the technology for like wireless remote controls for TVs and some RC cars. Well, we use it to actually send commands to other robots. So you'll be able to tell like a fleet of rovers to all start going or all stop, or send a command to a Bolt and have it do a dance or a move or display something on its screen. So the infrared's really cool. There's 4 infrared spots on the Rover, one in the front, one in the back, one on each side. So you can kind of actually get sort of a display of what other robots are around you using this. It's really a cool, powerful thing, and we just can't wait to see what teachers end up doing using the infrared. Another thing underneath the Rover is a color sensor. Really cool. You can get the RGB value that the robot thinks of that color. And so say you had some masking tape or something you bought from one of your hardware stores, you could kind of make a box on the ground that's out of red tape or blue tape, and then tell the Rover, don't go over that tape. Once you see that color, stop. So the color sensor is pretty cool. You can use it in a lot of different things like mapping or mazes or really just storytelling. It's really going to add a lot of fun stuff to the Rover and just the SpheroEDU platform. And then one of these big things that we talk about is this vector-based control system. That's actually the magic about this robot. We were talking about it earlier. I've made tons of these, maybe 10 or 15 of these robot-based platforms. And it's usually not the mechanics that are the hard part. You kind of put wheels on a base platform. It's all the other stuff. You got to get a battery that works, and a motor controller or like an H-bridge, and encoders for the motors, and then get an IMU, so an accelerometer and a gyroscope and a magnetometer, and kind of get all that data sorted. And then by the time you get all that working, it's actually really frustrating to get all that working and say, just go straight for 1 foot, 12 inches, go perfectly straight. So the vector-based control system on Rover is the same one that's been on Sphero and R2-D2 and all these other robots. So it's really tried and true and tested. And so it can, take a beating. It can take it into schools, but also from a robot programmer's perspective, I don't have to do all that other stuff. I can actually get straight into Raspberry Pi or into any other thing. So it's really awesome. And then the one last technology that you hear about on our Rover is the UART port. So what does that mean? Why are we talking about it? Let's get into it. So one thing about, actually I'm going to go to UART port right now. One thing about the UART port is that's actually how you talk to Rover. So we often talk to Rover through Bluetooth using the SpheroEDU app. So you're actually using Bluetooth, but you're sending the same kind of data. So on the robot is this 4-wire, 3-wire interface. You only need 3. So really you only need ground, RX, and TX. And so what that means is the ground is kind of like the connection. That just says, like, we're robots and we're connected to each other. And then the RX and TX, so RX means receive. So that means receive the signal. And the TX means transmit, so transmit the signal. And that's always kind of talking about the device that you're on. So if you're talking about the rover's TX, that means that's the rover's transmit line. Or the rover's RX, that's the rover's receive line. And so over that serial line, you're always sending API commands. So this is an example of what the API kind of looks like. It kind of comes in these packets. So you send a packet over the serial interface. That's how you communicate with a rover. Now here's a cool graphic of what I'm trying to talk about. So on the right side, you see that we use Bluetooth to communicate with Rover, and you can send commands through the SpheroEDU app. So without anything extra, you can get your Rover and use the SpheroEDU app and do all the cool community and content that we already have in there. So everything from the Pythagorean theorem to, the circulatory system to any sort of cool lesson in the SpheroEDU app, you can do that with Rover right out of the box. But that UART port that we keep talking about, the Universal Asynchronous Receive and Transmit port, so basically just stands for like a line. Like we use them all the time using USB. So it's about the same thing. It's just a computer line between the rover and any other device where they can send commands. So on that UART, we're going to officially support 3 platforms. So meaning on top of this rover, officially from Sphero, we will support Raspberry Pi, Arduino, and Microbit. So if you're familiar with those 3, computer platforms or processor platforms, you'll be so familiar with this rover, it'll be, very easy. The SDK will be available. We'll also make our API available to everybody. So what that is just the lowest level commands you send to this robot, kind of for the super nerds out there. If you want to make your own SDK or if you want to just send it raw commands, this is how we communicate with the rover. So that SpheroEDU app is sending this, raw commands to the robot. We just make that exposed so everybody else can send these commands. It's led to really cool innovation before for Sphero. So if you've ever used any of the platforms like Cylon.js or GoBot or the robot operating system, those are kind of wrappers around our SDK, and they can send commands to robots and interact with other robots in very fun ways. So if this is complicated, don't worry too much about it. We're just showing that there's kind of 2 cool ways to communicate with Rover. One, the SpheroEDU app, program it all day long in both JavaScript and blocks. And then 2, if you want to get kind of more fancy, add a weather sensor or pressure sensor or temperature sensor or light sensor, and you want to add some more information to your project, that's what the UART's for. That's where you can put projects on top of this robot and send them along, driving around, collecting data. So we kept talking about the Raspberry Pi. I just want to pop this up here real quick. First of all, the Raspberry Pi Foundation is awesome. What they've kind of done for single board Unix computers out there is, transformational to everybody. You see them all over the place. So kudos to Raspberry Pi. And the cool part about it is it's a little computer. So on your Raspberry Pi, you have HDMI out. You have a LAN, so like the network port. You have USB, so you can connect like cameras or really anything that's USB. You have audio in and out, and then you have power. but you also have this header. So this header is just like a bunch of, little pins sticking out, and they give you access to all sorts of cool parts of the Raspberry Pi that, normally you don't get to mess with on a computer. So GPIO, the general purpose input and output of a computer, you usually don't see that. But for a Raspberry Pi, they've made it exposed so that we can actually connect Raspberry Pis to all kinds of other computers or robots or kind of whatever using a serial port. So the word serial port and UART are kind of going to be interchanged here. They are different. If you want to get super in-depth and nerdy on us, go ahead and go to YouTube. There's a really good video about what a UART is and how the serial port works. It's way too advanced for this. Basically, we run our serial port at 115K baud. That's about all you'll need to know. It's 115-200 baud rate. Once you get used to like using a serial port, that number will be kind of matched in your head. But basically, that's the baud rate we use. And over here, we're going to actually connect our Raspberry Pi and Rover using GPIO 14 and 15 here on the diagram. So we're going to connect it up and test it. So as you see in this diagram, one big thing that you always got to remember is you're connecting the TX on one device to the RX on the other. So, and the RX on that device to the TX on the other device. So meaning I'm sending my transmit to your receive and your receive to my transmit. I'm kind of showing it here on the diagram, but it's something that kind of comes up is, should I connect the TXs together or the RXs together or what? No, you connect the ground together, and then Raspberry Pi's TX to Rover's RX and Raspberry Pi's RX to Rover's TX. So it's kind of how you'd connect these robots up. You got these 3 cables. I actually have one set up on my desk, and so I'm going to show you how I connected to that through the Raspberry Pi, and then I'm going to pull open the REST-based API that's on this Rover and just send it a few commands to turn it different colors, and you'll see that it's literally that simple. We had a Raspberry Pi that we got up and running, and then just installed our SDK, and kind of here's how it works. So we'll switch over to the camera feed for the Rover. One thing I'm going to do is wake it up. So what you can see here is I have my Raspberry Pi. I'm with the 3 wires here, ground, RX, and TX, and I didn't get too detailed, but they're connected directly to this Rover through the UART. So we have the grounds connected, the RX from this is to the TX of this, the TX, or the RX of this is the TX of that, and so that way they can send commands to each other. Let me send one over the API real quick to kind of wake him up. So you notice that this Rover is actually going through what's known as its bootloader process. It's just waking up and doing this little rainbow. So now, if you want to switch me back over to my screen here, one cool thing is the Swagger UI. So this is actually how you access any of the REST-based commands that are on the robot. So as you see, here's the Sphero SDK. I already got that Raspberry Pi up on my network. In the next live stream, so next Wednesday, we're going to kind of sit down and just go through it, opening a Raspberry Pi and setting it all up. But we had already kind of got this Raspberry Pi online, so it's on this network. We are on the same network, and so I actually just type in the Raspberry Pi's IP address here and what port, so 2010, and you get this. And so this website that you're seeing here is actually hosted on that robot. It's hosted on the Raspberry Pi. I previously, to wake it up, just executed this command here to wake it up. And so I'm actually going to, I'm not going to get into the details here, but I am going to turn the LEDs red. What I set right now was the green command. So as you can see, the robot has turned green. So we have green headlights, green side lights. And now I'm actually going to change all of this to let's turn it to red. So again, I will go into the details of this later. Are we on the computer screen? Cool. So I'll go into the details of this later. But basically, when I execute this, if you'll switch over to my Rover, what you'll see is we executed that command and it turns the Rover red. So pretty basic, right? That's pretty simple. We're just turning a LED red and green right here. But the real amazing part is we're doing that over the UART. So as you're driving around with your Rover, you can actually send commands over the UART having different colors, different roll commands and or drive commands. You can get all the data from this rover. So did you collide with something? You know, what's your acceleration? You can also get all the color sensing data. So this interface here is super powerful. You can get all the status. You're able to send commands and use commands. And this is still just a work in progress. If you signed up for our hackathon, or you're going to come out and see us for that, we're going to have a really awesome working version of this, API documents. It's going to work on Node.js and Python. So if you're familiar with those languages, you kind of feel right at home with using Rover and interacting with it. So please just check out our the rest of the tiers on Kickstarter. We have a bunch of cool stuff left. A lot of it's gone already. If you wanted to name our conference room something inappropriate, somebody already took that one. But there's a lot of other cool tiers, and so also hit us up about any questions. We are keeping a great eye on that, and so if you have any questions about how it works, or is it too advanced or too simple, we can answer all those questions on Kickstarter. So please come support us on Kickstarter. Again, I'm Adam Wilson, founder at Sphero, and thanks for joining us.